Okay, so these were the two exponential forms we studied. Now this is really the main one, and everything actually can fit into this form. Even this problem does. The base is just this. This is our base. The exponent is this. And this is our initial amount. So even this formula that we use for compound interest actually is in this form. Now, this is definitely what we use whenever we see the word, what do we look for? What word are we looking for to use this formula? Yeah, compound. You see the word compound in a sentence, that's the formula you're going to be using. Okay, so this one says we start with 100 fruit flies. The population doubles every week. How many fruit flies will there be in 6 weeks? So this is an exponential problem because it's doubling. We're multiplying by the same number over and over and over again. Unfortunately, it's fruit flies, and they're annoying. All right, so in this case, our initial amount is that 100. So A is 100. The population doubles every week. So our multiplier, our B is 2, and it's defined, our time unit is in weeks. So how many fruit flies will there be after 6 weeks? So they gave us this in weeks. So this is straight back review. So it would be 100 times 2 to the 6th. And so our total population after 6 weeks would be 6,400 little fruit flies. Number 2 is about a population decline by a percentage. And when we have percent growth or percent decay, our multiplier, that B, is going to be 1 plus or minus the percent, depending on which scenario we have. This time we have decay because we are decreasing. So this 1550 is our initial amount. That's our A. It is decreasing by 8%. So our equation would be 1 minus. Now, how do we write this percent as a decimal? 0.08. And this is percent each year, and our time period was in years, so we don't have to do any adjustment there. We just put 10. So this would give us our population after 10 years. And so we'd say 1550 times 0.92 to the 10. Now, we are talking about students here. We are talking about people, and it's a situation where we would round up to the previous because it's decay. Growth, we round down. Decay, we round up. So we would say that our population after 10 years would be down to 674 students. That'd be really sad. Because Starks Mill is close to 1,500. Can you imagine if 10 years from now there are only 670 kids here? That'd be weird. Wonder if I'd have a job. Maybe. Alright, number 3. John invests $2,500 at 5% interest, compounded quarterly. Okay, so we see the magic compounded word. And when we see compound, we're going to use compound interest. Okay, so his initial investment was at $2,500. The rate, which is R in our formula, is 0.05. N represents the number of times something happens each year. And quarterly tells me it happens 4 times a year. So 4 goes here, and 4 goes here in the formula. And T is time in years. So John's going to save for 10 years. Good job, John. Okay, so if we punch this in correctly, John should have about $4,109.05. Okay, so this is all our review. This is what we did at the beginning of this unit. So now we're going to see why we studied logs in the first place. So we can answer these types of questions. When will you have? And that can be important. So this says we're starting off with 25 fruit flies. They're doubling. How long will it take for there to be 880 fruit flies? So it's the same scenario, but this time in our y equals a times b to the x, we're solving for x. We're solving for time. So our initial amount is 25. It's doubling, so this is still 2. It's every week. How long will it take for there to be 880 fruit flies? We know the total. We don't know the time. So let's do our little trick. Just the base raised to the exponent. That's what we have to get by itself. Just the base raised to the exponent. So what needs to go in this case?
25.
The 25. We have to divide by 25. And so that gives us 35.2 equals 2 to the x. And since I do not know what power to raise 2 to get 35.2, I'm going to have to use logs to solve this problem. So I'll take a log of both sides. And when I do, that x comes out in front. I'm running out of space, so I'm going to come back over here. And now what do I need to do to solve for x? Divide. Divide by log of 2. So it becomes x equals log of 35.2 divided by log of 2. And we definitely need to punch that in. Okay, when we're reading this question, it says how long will it take? The question did not define our unit, so when we write our answer, we should define our unit. So it was originally given to us in weeks, so this is weeks. If this were a word problem, you could say during the 5th week, because 5.138 would happen during the 5th week. Any questions? All right, here we go. The population of a town is 12,500. This says it's growing at a rate of 3% per year. That's a very high population growth rate. How long will it take for the town to reach 18,000 people? So the initial amount is 12,500. We're growing, so it's 1 plus the rate. We want to know how long before we reach 18,000. Okay, so this is what I'm trying to solve for. My base raised to my exponent. So I have to get rid of the extra stuff. So in this case, what needs to go? The 12,500. All right, so this divides nicely. If it didn't, we could just leave it as the fraction, but this gives us a nice terminating decimal. If we get a decimal that doesn't terminate, you just really want to leave it as the fraction. Okay, so now I'm left with a base raised to an exponent equals an answer part. So once I get it in this form, I can take the log of both sides. And when I do, that exponent comes out in front. So to solve, I would have log of 1.44 divided by log of 1.03 is exactly equal to my time. And now I'm going to approximate. Okay, so did you get 12.336? All right, and since the unit was not defined in the question, how long will it take? You need to define the unit in your answer. Okay, number 3. John invests $500 at 3.5 compounded monthly. How long will it take him to have this much? Now this is a really good problem here. Compounded monthly is generally what happens with our funds. So he's starting out with $500. The interest rate is pretty fabulous for current day and age. 3.5%. That's a great rate. I'd love to have that one. Monthly happens how many times a year? 12. And what we want to know is how long. We want to know this time. So that's the part that's missing. But he wants to have $3,000. Maybe he's going to Disney World. That's about what it takes to send the family to Disney World. A little bit more than that. But that's close. Maybe it's just 10. Alright, so John, you probably don't want to go to Disney World. This is probably what you needed to say to go to the Super Bowl, wasn't it? Mm-hmm. Yeah, that's what it was. Alright, so we want to get this part by itself, so the 500 has to go. So really we're saying he wants to have 6 times as much as he started with. Alright, so this is a little more convoluted looking. It's the same exact process, it's just not as pretty. So here we take the log of both sides. And when we do, this can come out in front and become multiplication. Okay, so we have to divide by this crazy looking stuff. Okay, so let's do log of 6 divided by log of 1 plus 0.035 divided by 12, close parentheses, boom. You get 615-ish. Leave that number in your calculator. And what's the last thing we have to do now? Divide by 12. Aww. Bummer, John. Be nice if this were days, but what's our unit of measurement? T in this formula is always time in years. In compound interest, T is time in years. That's how often it's compounded. So 51 years later, John could go to the Super Bowl. I think I'd come up with a different savings plan. Yeah. All right. Want to talk about a formula that's on the back of your worksheet too? Here.